Alright, so today I'm going to teach you guys how to debug our project, and to do that, I implemented a bug into our project. And as you can see, when we crouch controlling the character on the right, the character on the left, so our third person character that should be matching what we're doing on the right side, is not matching properly. So something weird is happening in here, and we're going to go through the process of diagnosing the issue and then fixing it. So then we'll go over to Jira and put in that task, implement Debug HUD, and I'll go over the description real quick. So basically, this Debug HUD is going to be a way for us to see live what's happening behind the scenes. And we're going to make a base one and one for animation and for movement. And it's an engineering task, and it's under the player character epic. So we throw that into in progress, and then we'll get to it here. So the first thing we're going to do is go into our UE5 solution file, and I'm going to show you guys how the debugger works. So what the debugger is it allows you to pause the code as it's running, so you can go in and see exactly what's happening. And just hearing what it is, you can imagine how valuable that can be and how useful that can be. So first, we're going to go into our character.cpp, and we're going to put what's called a breakpoint on this line of code right here, so the enhanced input component, because this is in our setup input function. And the first thing we need to check is to see if this input is actually being bound properly. So now when we press local Windows debugger, it's going to launch the project. And then once it finally does launch, I'll skip ahead until it does, we'll see a whole bunch of diagnostic tools and engine logs coming up, which can help us try to figure out what's going on. But despite all those helpful tools, you'll notice that the engine just pops up as it usually does, and we'll open it up there. And then almost immediately after we initialize, we're going to get our breakpoint triggered. And what this is telling us is that the code is stopping right here, so we know that this input is being bound correctly. So that's a good sign for us, and that isn't the issue. So the next thing we're going to check is the input comp. And we're going to go in here and go to our command crouch function that we're binding to. So we'll throw a breakpoint in there, and then now we can see if that's being triggered. So to suspend the pause and continue, we press the continue button. And notice that we hit this breakpoint again, and that's because we have two characters playing right now. So we're getting hit with the second instance of that breakpoint. So we'll press continue again, and it won't get triggered again. So then we'll go over to the character we want to test, and we'll click into here, and then I'll press the crouch button, and see it brings us to this command crouch. And then from here, we can do a whole bunch of things. So there are controls up there, so we can press step into, and what that's going to do is step into what that function is doing. So then we get brought to our get and check functions, and we can step into there and keep going through, because we need to check that all these are valid to run our crouch function. So then we'll keep stepping in, and we eventually get brought to the character movement component function, where we check if the character is crouching. So now we can see that, how I hover the mouse over, and we can see what the variable is. So notice here we can see what that is as well. And we can press this step out because we kind of got a little bit too into the weeds there, so we want to go back out. And then we can press step over or step into again. And there we go. So now we're on the crouch function, because that's what gets triggered when our process crouch is triggered. And we can see what that is, and we can see what the references are to the different variables. So this is really valuable, because if any of this looked wrong, then we could tell that that was part of the issue. What you'll find, though, when you're debugging your code is that certain local variables will be optimized out when we run in this development editor configuration. So to get more of a picture of what's going on, we can switch the game type to debug editor. and that will optimize out less variables. And you don't want to run like this all the time because it'll make your frame rate way worse. But when you're actually debugging, it's a good thing to do. So I'll skip ahead until it launches again. And as always, if you get permissions pop-ups or something like that, just give them permissions so that everything will work. And to demonstrate why the debug configuration is good, I'm going to go into the anim instance CCS and continue and see we can see what the delta time is. So that typically would be optimized away so we wouldn't be able to see what's happening there. So that's the difference between running in that configuration, and it can definitely be worth doing if you're using the debugger. So see, we step through the rest of this function as well, and we can stop it, and at that point we weren't able to find what the issue is. And sometimes you'll find that you can't figure out what the issue is using the debugger, and that's when we turn to our Debug HUD. So we're going to pop open the engine here and we're going to create the Debug HUDs. But oh wait, we forgot to switch back to Development Editor. So we need to make sure we do that before we launch the engine again. So we'll build the project. And by the way, you have to build once you switch the configuration or else it won't actually be running in that configuration. So we'll build and I'll skip ahead until it's done. Alright, so we're all built, and now we can actually launch hide, seek, survive, so we can make these Debug HUD classes. And these are, of course, going to be made in our CCS Core plugin. So we'll go down there, and these are going to be a child of the HUD class. So that's a built-in class to Unreal, and we're going to make one called Debug HUD. And right here, I make a little mistake where I name the class the wrong thing. And I will briefly show you guys how to fix it. So what we're going to do is go in here, right click, create new C++ class. And we are going to scroll down to HUD, next. And we'll make a folder called Debug Huds, because we're going to have quite a few of these, so we need a folder. And we'll call it Debug HUD, and this is where the issue is. It should be called Debug HUD CCS, not just Debug HUD. So I think I went over this in a previous video, but I'll show you guys real quick how to fix this naming issue. So we'll skip ahead until we're done compiling the code. And the first step to fix this naming issue is we need to change the names in the code files themselves. So you'll see I change it to CCS, and I change the class name to CCS, and the .generated file as well. So now we're all done with that. We can close everything down, and we can go into our file explorer for hide, seek, survive, and we want to go into our CCS Core plugin source folder. And once we're in there, we need to change the names of the code files to match what we just put in. So we'll add CCS, and then we'll go to private, and we'll do the same thing. So we go in there, Debug HUD, CCS. Okay, looking good. So now we're going to regenerate the project files. So we'll delete binaries and intermediate at the top level and both of the plugins. That's how you tell that the files are actually being regenerated. And then we'll go back to our U project file, show more options, generate Visual Studio project files, and then to check to see if the files actually got regenerated, then we need to go into our last plugin and make sure the intermediate pops up. And there it is, so we're good to go. So now we can go back into our solution, and we're going to have to rebuild hide, seek, survive to make sure all those changes actually worked. So see, it can't find that file anymore because it isn't there. We renamed it. So now we can see that they're both there. And don't worry about the red squiggly under the .generated.h file, because that will be generated when we build the project. So I'll skip ahead until it's done. Okay, great, build succeeded. Now we can launch hide, seek, survive and make our child debug HUDs for animation and movement. Alright, so now we're in the editor and we can go to our Debug HUD CCS. right click, create child, and get rid of that my at the start, and we'll call it movement. So Debug HUD movement CCS. See, it takes me a couple seconds to click create class because I don't want to screw it up again. And I'll skip ahead until this live coding is done. Okay, live coding is done. Now we're going to go make the next one. So same thing, right click, create C++ class, child C++ class that is. And this is going to be the animation Debug HUD. So then we'll create class again, and I'll skip again until we are all done. Alright, live coding succeeded. Now we can go into Visual Studio and start filling out the code for these classes. So we'll organize everything a bit here. And the first thing we're going to need to do is declare our Debug HUDs friends of the class that they need. So our animation is going to need our anim instance CCS, and our movement is going to need the character movement comp CCS. So we'll open both those up. And declaring a class a friend basically means that it has access to all of its variables and functions regardless of their classification. So if we have private or protected, typically other classes won't be able to access that, but because we call it a friend class, they're going to have access. And that's very important for the debug HUDs, because what we're doing is just reading what the variables are and printing them to the screen. So to do that, we're definitely going to need access. And right here, I make a little mistake where I make them U debug HUD instead of a debug HUD. So later when we go to build, we're going to get an error, and you won't get that error if you call them a debug HUD. So do as I say, not as I do. So we have friend, class, and the class notation there is just forward declaring. But because it has nothing to do with the rest of the class, I like to declare the class down here so I don't get confused later. So again, make that a debug HUD, not U debug HUD. Okay, we can close that down, and we'll move over to the anim instance, and we're going to do the exact same thing, but for the animation debug HUD. So again, make it a debug HUD, not U debug HUD, or else you're going to get an error. But yeah, that's all we have to do, and now we have access to all the variables and functions within these classes, despite them being declared private or protected. And we can close down the editor as well to kind of free up some resources and get the log back to build so it doesn't get flooded. Alright, so now that that's done, we're going to start working on our debug HUDs. And I'm going to paste in a whole bunch of code, and don't worry, I'm going to go line by line. So you're not going to get lost, I promise. Okay, so we'll do debug HUD ccs.h first. And for this system, I have to credit Rob Baker. He has a class on Udemy that I took a really long time ago, and that's where I learned how to use the debug HUD stuff. So you'll see I credit him in the description, and I'll also put a link to his class in the description of this video. Just be aware that it is paid, but it's definitely a good class. So shout out to Rob. But anyways, if you read the description, you'll see that this debug HUD is responsible for printing information to the screen. And there isn't actually going to be information in this class. It's just going to contain the functionality for our child classes to print stuff to the screen. So we have the constructor and typical notation there. And all we're going to do there is select the font that we're going to use. And then we have this add text. And what this is basically giving us a way to render statistics to the screen using this render statistic function that we're going to make. And that is how all the statistics are going to be rendered. And we'll use force inline so we can write the function here in the header file, just to make our CPP file a little bit cleaner. And then we have add float, which is just the exact same thing, but with a float. Add int, exact same thing with an int. And yeah, these are all pretty similar. We have the title, value, and then the color. And then we have add bool as well, which just again, same exact thing, except for we need the bool to text because we want to actually type out text instead of just showing the bool. And then we have draw HUD here. And draw HUD is the function that's actually going to be writing things to the screen. And we're going to set the values to 50 just to make sure that the HUD appears in the upper left, which seems to be a good place to put it, so we'll keep it there. Then the next line, we have a function that converts C strings to text, and that just means C, the predecessor to C++, and 4 strings that we get in that format will convert them into F text, which is what we need to print for our logs. And then same thing for the bool to text. It's going to basically print out true or false depending on what our Boolean value is. And those members being static means that we don't need an instance of this class to call the functions. So later on in the project, if we need to convert a C string to text, we can call this function anywhere in the entire project and it'll work. So pretty cool. And then we have render statistic. So this is where our statistic is actually going to be rendered. So pretty important stuff there. We'll fill that out in the .cpp. And then we have our main font variable. And then a few offsets and coordinates. So we have a horizontal offset between the title and the statistic. We have the X and Y. And then we have the line height. So those are just all constants that we use. And now we'll move on to the .cpp. And all we're really going to be doing here is filling out the constructor and that other function, render statistic. So again, I'm going to paste in a whole bunch of code. Don't worry about those red underlines. They'll go away as the engine remembers what those include files are. So as you can see, we're just using the construction helpers to grab the font at that specific place. And you don't want to use these unless you know for a fact that what you're looking for is going to be there. And the engine font, that will never move. So it's okay to use there, but I wouldn't use it otherwise. And here we have our render statistic. And the first thing we're going to do is create our canvas text item for our statistic title, and then get rid of the shadow. And then we want to draw that to the screen. And then we do the same thing for the statistic, and then we draw that to the screen. And then at the end, we change our Y coordinate so the line height will be ready to render the next statistic. So as you can see, when we make each of the canvas items, we are using our inputs. So important there, and that's how they are drawn. And now that we're all done with that, we'll move over to our animation debug HUD. And again, we're going to paste in a whole bunch of code. And as you can see from the description, we're just going to be printing valuable information about the animation system. And then we just have that draw HUD function that we're going to be overriding from our parent. And then we'll swap right over to the .cpp and paste the code in for that. So get rid of that space, paste it all in. And all we have here is our draw HUD function. So first, we're going to call the parent's version to make sure none of that gets lost. Then we're going to try to get our character reference. And if it doesn't work, then we're just going to return out. And then once we have that, we're going to try to get our animation instance reference using the cast and get anim instance on our mesh. And important that we're getting the anim instance from our third person mesh, so we have all the information we need. And then after that, we print the actual values to the screen. And that last line, spoiler alert, we're going to be working on aim offset in the next episode. So don't add that. I actually accidentally added that, and it's going to result in an error. But you won't get an error if you don't have that line. So definitely take that out, but you want the other 3 lines where we are adding the 2 floats for speed, direction, and the Boolean for is crouching. And then we'll move into the Debug HUD movement. So we'll get that filled out. I'll paste in a whole bunch of code again, and then we'll talk about it. But you'll see it's pretty much exactly the same thing as the animation, except for with movement. So just the override of the draw HUD, and that's pretty much it. And then we can move over to the .cpp file, and then we'll paste in our code. And same kind of thing here, so we get the character reference just like we did in the animation one. And now we're getting the character movement component instead of the animation instance. And then same thing, we just print the variables to the screen. And the only one that's kind of interesting here is the third one. We're printing out an enum. So that's how that works. And now that we're done with all our code work here, we can build and launch the engine. And you guys shouldn't have any errors if you were following along. So I'll just fast forward until our build succeeds. Alright, so now we're all packaged up, and we can launch the engine, enable these debug HUDs, and try to figure out what the issue is. So to do that, we're going to go into the content drawer, get out of the plugin, go to core, and go into our game mode. And that's where we're going to put in our HUD that we want to use. So game mode HSS, and we can open the full blueprint editor just to make it easier to see. And here we're going to swap in the movement one first. Okay, so save and it'll check it out. Then we can press play. And now we're going to be able to see the helpful information. So I know the font is a little bit small for you guys, but as you can see, we're getting a live reading of our speed, our walking movement mode that we're in, and whether or not the crouch variable is pressed. So as you can see, the crouching variable is actually changing correctly based on my input. So we can tell that that isn't the issue. So it's probably something to do with the animation. So we're going to close out of this and swap to our animation debug HUD to see what the problem is there, if there is one. Okay, so we'll swap it over to animation, compile save, and press play again. And now we'll see we have our animation information. And let's see if the is crouching is being applied correctly to the anim instance, which is what this is checking. And it looks like it is. So this means everything is being fed to the animation blueprint correctly. And that tells us that this is probably an issue with the animation blueprint. So we're going to go there. So we'll go to characters, and then open up that third person animation blueprint. Okay, so we'll open that up, and we'll check out our upper body state machine first and see if there's anything wrong in here. So we have our walk state, and that looks fine, so that's the blend space it's supposed to be. Our crouch state also looks fine. And then here, so our rule from walk to crouch looks good, but wait, our crouch to walk is backwards. So right when we're in the crouch state, we're going to be checking to see if we're crouching, and then we're going back to walk. So these rules are exactly the same, the walk to crouch and crouch to walk. So that's going to mean that our animation blueprint is going to be all screwed up, and that's what the error is. So now that we know what the error is, I'll fix it here as well as in the lower body, and then I'll fast forward to when we're testing again. And would you look at that? It is all working again, so no jittering. When I press crouch, we're actually crouching and uncrouching properly. So yeah, after all that, we figured out what the error is, and you guys got to see the debugger. So good stuff. And now we'll quickly speed run the review process. So we'll kick off a build real quick. And it succeeded, so we can pop it open and take a look. And yeah, everything's working in here as well, so we are good to check in our perforce changes. So we go to submit, and we take a quick look and send it on its way. Then we'll go over to our board, move our task into done, leave a little comment saying what change list it was, and we'll call it a day. As always, thank you so much for watching, and I'll see you guys in the next one. Later.